The 10th of May 1940, Liège Sector. A dozen silent gliders and 80 sappers turned Europe's strongest fort into an opening in the line fast enough to matter for the Meuse crossings. The Albert Canal cut a clean, defensible line north of Liège. Fort Eben-Emael sat on a limestone rise commanding the canal's most direct bridge approaches. Belgian engineers had integrated multiple armored cupolas and casemates into a reinforced concrete massif intended to cover the Vroenhoven and Veldwezelt bridges with overlapping fields of fire. The fort's concept was classical: fixed guns with narrow traverses, deep galleries, and a roof of earth and concrete that assumed the attacker would come horizontally, not from above. At first light on May 10, 9 DFS 230 gliders, plus or minus by source, carried approximately 75-85 assault engineers from Sturmabteilung Koch toward the fort's roof. Their task was less to overrun a garrison of more than 1,000 than to remove, within 30-60 minutes, the key weapons that made the position decisive for the river crossings downstream. This opening move reflected a specific problem statement. German planners needed the Albert Canal bridges intact to move vehicles at a rate that preserved operational tempo. A single span could lift only a finite number of trucks per hour, while pontoon alternatives would impose delays measurable in hours to days. Uncertain, exact Belgian bridge throughput figures. What was certain was the geometry. If the fort's principal turrets and observation posts could be blinded or disabled quickly, counterfire against the bridge seizure detachments at Vroenhoven and Veldwezelt would collapse, and the bridges could be held long enough for follow-on crossings. In that calculus, time, even minutes, was the most valuable metric. The airborne approach addressed the fort's design assumptions. Cupolas and embrasures optimized for low-angle threats could not traverse or elevate to engage a team landing directly on the roof. Gliders provided a mass quiet insertion. Each DFS 230 could carry a sapper team with specialized charges, flamethrowers, and tools, yet arrive without the acoustic warning of engines. Landing on the fort was the only way to bypass its guns, Assault Leader Rudolf Witzig noted in post-action reflections, paraphrase, "This was vertical envelopment aimed at the fort's neural nodes observation, range finding, and specific weapons rather than a general assault on the perimeter works." The engineer teams carried novel explosives whose effect relied on charge geometry more than sheer mass. Hollow charges, placed correctly, concentrated explosive energy to perforate armor and concrete around cupola bases and turret roofs. Contemporary Belgian reports described violent explosions upon the massif, followed by disabling of cupolas, a phrasing consistent with shaped charge mechanics, translated excerpt, paraphrase. Unlike general demolition, which requires weight and time, these charges were designed for speed and precision. The measured outcome was not rubble volume but weapon silence. The glider landings were timed with the bridge seizures. Assault groups on the ground moved on the Vroenhoven and Veldwezelt bridges almost simultaneously. German accounts and later analyses put the number of critical spans held at 2 to 3, with the Vroenhoven and Veldwezelt bridges the most consequential for the immediate tactical problem. Holding even 2 intact road bridges multiplied throughput compared to ferrying across, at vehicle densities typical of early war motor columns, uncertain, exact per-hour vehicle counts. The difference between 1 intact span and 2 could be hundreds of tons of supplies per day. Karl-Heinz Frieser would later argue that such moments were less about a mythical blitz doctrine than about improvisation, tempo, and the destruction of key nodes. The Blitzkrieg legend, paraphrase. The Belgian garrison, for its part, was not fragile by composition. With over 1,000 personnel distributed across galleries and posts, it could generate sustained fire if its command and observation links held. But that resilience depended on cupolas that could observe, range, and correct. By landing directly on the roof, the sappers removed the fort's ability to coordinate its own assets. In practical terms, neutralizing a handful of turrets and posts within 30-60 minutes, had a disproportionate effect. It converted a fortress into a blind hillock at the precise time ground units needed to pass over the canal. Metrics mattered to higher command because they translated directly into movement. 9 gliders equated to 9 assault packets, each with a small set of targets. 70-plus sappers against a garrison, an order of magnitude larger, seems asymmetrical, but the objective function was not enemy strength destroyed. It was weapons silenced by minute X. In that frame, a measured 30-60 minutes to neutralize principal weapons aligned with the tempo required by 6. Army to reach the Meuse crossings on schedule. Fortresses are not defeated by weight alone, but by identifying and striking their indispensable organs. Witzig summarized after the action, paraphrase. Seizure concurred in analytical terms. Eben-Emael showed that tactical invention, not mass, opened the Meuse, paraphrase. A Belgian post-action note, bleak but accurate, recorded. Enemy landed upon the massif. Cupolas disabled. Observation impossible. Translated excerpt, paraphrase. Each statement, from different vantage points, pointed to the same causal chain. Vertical approach defeated traverse limits. Shaped charges defeated metallurgy, and bridge capture converted tactical surprise into operational mobility. By exploiting the one axis, the fort could not contest its roof, and applying charge geometry against armored nodes, a small airborne force converted a 1,000-man fortress into a temporarily blind position at the exact hour when intact bridges multiplied German road throughput toward the Meuse. The 10th of May 1940, Fort Eben-Emael, first 60 minutes on the roof. Touchdown turned intent into engineering. As the 9 DFS 230 gliders slid to a halt across the grassy crown of Eben-Emael, assault teams broke down into pre-assigned packets, charge layers, flame operators, security men, and runners. Each packet moved to a mapped objective, armored cupolas, observation posts, and casemate ventilators following routes rehearsed against mock-ups in Germany, historiography. Many accounts concur on rehearsals. Exact site details vary. The metric that governed their work was not territory seized, but weapons silenced by minute marks, 10, 20, 30. Against a garrison of 1,000 plus, roughly 75-85 sappers carried less than a ton of explosives in total, but the geometry of that explosive mattered more than weight. The principal devices were hollow charges designed to penetrate armor and fracture concrete at close range. Flamethrowers suppressed apertures long enough to emplace the charges without return fire. The first targets were the fort's eyes and hands observation posts, and the cupolas, whose traverse arcs dominated the Albert Canal bridgeheads. Roof-level approach negated traverse. Most cupolas could not elevate high enough to engage attackers above them. This asymmetry translated into time saved. Placing a shaped charge required seconds of exposure versus minutes of approach if attacking from ground level. Belgian reports logged explosions on or near the cupolas within the opening quarter hour and immediate loss of observation on at least one sector. Belgian garrison notes, translated excerpt, paraphrase. That loss of observation multiplied downstream effects. Without corrected fire, the fort's guns ceased to threaten the Vroenhoven and Veldwezelt seizure detachments at the critical window when bridges were being held against counterattacks. Charge employment followed simple arithmetic. A small magnetic or set charge-shaped device, firmly seated on the armored surface or at a base seam, directed a metal jet into steel. Larger plate charges, where carried, cracked reinforced concrete covers and mounting rings. The sapper's goal was not the spectacular wrecking of a turret, but the quicker outcome of jamming traverse, breaking periscope assemblies, or blowing ventilation that forced crews to evacuate. It was enough to blind and paralyze. Assault leader Rudolf Witzig later summarized post-action notes, paraphrase. In several cases, Flamethrower bursts preceded the placement to force hatches shut. In others, a follow-on charge finished what the first had started. The measured effect was binary for command, cupola silent or not, by minute 30. Chronology across sources converges on a similar arc. Within roughly 30-60 minutes, the principal roof weapons and key observation posts were neutralized or suppressed to the point of ineffectiveness. That timing aligned with ground action at the bridges, where 2 to 3 critical spans, most notably Vroenhoven and Veldwezelt, were either seized intact or temporarily secured. Even a conservative throughput estimate shows why this mattered. If a single road bridge could pass several hundred vehicles per day under controlled movement, uncertain, exact Belgian pre-war capacity tables, doubling the count of intact spans, raised daily tonnage by hundreds of tons, enough to sustain the early elements of 6, army pressing toward the Meuse. Tempo came from bottleneck removal, not from mystical speed, historian Karl-Heinz Frieser argued, using Eben-Emael as his case point, the Blitzkrieg legend paraphrase. Belgian defenders reacted as doctrine prescribed. Local counterattacks attempted to reach the roof. Interior crews shifted to backup observation and sound ranging. But the fort's internal mobility worked against rapid recovery. Moving men and equipment through galleries and shafts measured in hundreds of meters took minutes that the sappers converted into additional objectives struck. Communications degraded as observation failed. Fire missions without correction risked ammunition with little effect. A post-action Belgian note captured the dynamic. Observation posts destroyed. Communications intermittent. Cupolas disabled. Impossible to concentrate fire. Translated excerpt. Paraphrase. The defender's strength mass under concrete could not be employed at the decisive points, because those points were being disassembled from above. A leadership wrinkle underscored the plan's resilience. When Witzig's own glider was delayed due to a tow rope failure, widely reported, precise sequence varies, the en-roof teams executed by the book of packets and timings rather than waiting on orders. That autonomy compressed the action into the same 30-60-minute window despite command friction. In engineering terms, the operation had been designed to be parallelizable. 9 packets against 9 objectives, each with its own clock. By the first hour's end, the fort's combat power was not destroyed in absolute terms, but its decisive functions were offline where it mattered. No reliable observation across the bridges, key cupolas silenced, and interior movement forced toward defense and damage control. The numbers that shaped the day were stark. Fewer than 100 sappers, disabling a dozen-plus critical apertures and posts in under an hour, versus a garrison over 10 times larger, unable to bring its weapons to bear at the crossing windows. That delta minutes saved at the fort translated directly to hours gained at the bridges, and subsequently to days shaved off the advance to the Meuse. An old fortress can be made modern by the enemy's method of approach, Frieser noted dryly, paraphrase, meaning that the Germans had imposed a vertical, precision problem that the 1,930 seconds design did not address. The Belgian records agree on the outcome, if not the framing. Roof occupied by enemy. Main weapons out. Observation lost. Translated excerpt, paraphrase. Both statements point to the central finding. Once the roof could be reached quietly, fixed, gun traverse limits were not a disadvantage to be mitigated, but a vulnerability to be exploited. Precision packets, acting in parallel, converted traverse limits and observation dependencies into systemic failure within an hour, creating a throughput advantage at the bridges that amplified far beyond the fort's roof. The 10th of May 1940, Vroenhoven and Veldwezelt Bridges seizure and hold for throughput. The bridge seizures across the Albert Canal formed the second half of the problem that began on the roof of Eben-Emael. While the rooftop packets moved against cupolas and observation posts, sister assault groups from Sturmabteilung Koch, organized into small glider-borne detachments, aimed to land within meters of the Vroenhoven and Veldwezelt road bridges. Contemporary German designations for these packets differ across accounts, often rendered as Stahl, Beton, Eisen for specific bridges, but the functional brief was consistent: secure the spans intact, cut demolition leads, and hold until motorized relief arrived. Historiography, designations concur. Exact packet to bridge mapping varies by source. The timing tied the two actions together. If principal weapons at Eben-Emael fell silent within roughly 30-60 minutes, the bridge teams faced only local Belgian fire, still dangerous, but not the concentrated, ranged effect a functioning fortress could deliver. Landing distances mattered. Glider touchdowns that placed squads within 25-50 meters of the abutments reduced the time Belgian defenders had to fire or detonate charges. Where the defenders had pre-laid demolition, the German sappers' metric was simple: cut or disarm within minutes. A single intact span could pass hundreds of tons of traffic per day. Two intact spans, Vroenhoven and Veldwezelt, multiplied that figure and, crucially, offered redundancy if one approach jammed. Uncertain, exact Belgian peacetime capacity tables. Even without precise throughput data, the operational logic is clear. Doubling bridge count lowers mean wait times for columns and reduces vulnerability to a single failure. Initial contact at both bridges featured the same elements seen at the fort: speed, localized violence, and technical tasks sequenced to a clock. Charges were clipped, blasting caps pulled, and firing boxes seized or destroyed. Belgian defenders delivered rifle and machine gun fire. In some cases, partial demolitions warped deck plates or damaged railings, but left the spans passable to light vehicles once checked by engineers. At Vroenhoven, contemporary photos and after-action narratives note damage that required repair. Yet the bridge remained operational enough to justify holding it under fire. Securing two spans intact was worth the risk measured in small units, Karl-Heinz Frieser later argued, framing the trade-off as tonnage saved over days, the Blitzkrieg legend paraphrase. Holding actions then shifted to geometry and ammunition. Assault detachments, dozens of men at most, had to cover approaches from multiple axes while husbanding small arms rounds and explosives. Without fortress-directed artillery, Belgian counterattacks arrived in piecemeal fashion from nearby posts and village streets. The difference between a coordinated fort and bridge defense and the reality on May 10 was quantifiable in minutes and meters. Each minute without observed fire permitted the bridge squads to wire obstacles, emplace machine gun arcs, and prepare charges of their own to deny recapture. Bridgeheads stabilized because the fort could not provide corrected fire. A Belgian post. Action report acknowledged in substance. Translated excerpt, paraphrase. That admission underscored how the roof fight and the bridge fight formed a single system. Relief times provide another measurable, motorized elements. Advancing toward the canal needed intact crossings to maintain a march rate on the order of tens of kilometers per day. Even a delay of 6-12 hours at the Albert Canal would push subsequent Meuse crossings into a new tactical day, altering the correlation of forces as French and Belgian units repositioned. By mid to late morning on May 10, times vary by source, German relief began to reach the seized bridges, bringing heavier weapons and additional engineers. With reinforcement, the small glider-borne detachments transitioned from seizing parties to the forward edge of a broader bridgehead. What looks like speed is often the removal of a bottleneck, Kurt Student observed in a post-war reflection on early airborne operations, paraphrase. The Belgian side attempted countermeasures in parallel. Local commanders sought to complete demolitions where leads remained. Mobile troops probed the perimeters, but the window had narrowed. Once the principal cupolas at Eben-Emael were neutralized and observation degraded, indirect fire could not be ranged accurately onto the bridges without risking fratricide or waste. Counterattacks thus relied on direct fire and the courage of small units, which, though notable, could not break, prepared arcs backed by incoming German reinforcements. A post-action Belgian remark captured the dilemma. Bridge charges partly removed, Enemy holding with machine guns. Artillery support uncertain. Translated excerpt, paraphrase. Quantitatively, the bridge seizures converted early morning surprise into a day-long logistical advantage. 2 to 3 critical spans held meant that, even accounting for damage and traffic control measures, vehicle flow remained orders of magnitude higher than any ferry or improvised crossing could offer on short notice. If a single span could clear, for example, 10-15 vehicles per 10-minute cycle under traffic control, illustrative, uncertain, then parallel spans reduced average wait time per column and increased cumulative tonnage delivered to the far bank by evening. This was the operational tempo. The German High Command sought not abstract speed, but the sustained ability to deliver battalions, guns, and fuel across a water obstacle without pause. The bridge episode also clarified a doctrinal point. Air insertion was not an end in itself. It was a tool to shape ground maneuver by preserving infrastructure. The correlation runs through the numbers already established. 9 gliders on the fort's roof to 70, 5, 80, 5 sappers, 30-60 minutes to silence principal weapons. 2 to 3 bridges seized and held long enough for motorized relief. Each figure maps to a capability delta, remove observation, save spans, compress timelines. At Eben-Emael and the Albert Canal, minutes at the start became hours saved at the Meuse, Seizure concluded, placing the episode within the larger 6. Army push, paraphrase. Seizing and holding Vroenhoven and Veldwezelt converted rooftop surprise into sustained movement capacity. Intact spans measured in vehicles per hour kept the timetable to the Meuse intact and made the fort's rapid neutralization operationally decisive. May 10-11, 1940, Fort Eben-Emael interior defense, isolation, and capitulation. With the principal roof weapons neutralized by mid-morning on May 10, the battle shifted below the surface. Eben-Emael's galleries, concrete corridors running for hundreds of meters through the limestone, were designed to compartmentalize damage and allow the 1,000-plus garrison to maneuver between combat blocks, magazines, and command posts. In practice, the loss of observation and several cupolas forced Belgian officers to fight blind. Messages that once moved by telephone and periscope corrections now traveled by runner along passageways where a single blocked stair or smoke-filled shaft could add minutes to every decision cycle. The defenders still had numbers and ammunition. What they no longer had was a way to convert that mass into effective fire on the canal bridges at Vroenhoven and Veldwezelt. The German assault teams exploited that gap without attempting an underground siege. Their packets remained on the roof and around exterior access points, applying additional shaped charges and flamethrower bursts where hatches, ventilators, or periscope heads allowed. Each localized detonation accomplished 2 quantifiable effects. It disabled a discrete function, for example a rangefinder or traverse gear, and it injected fumes and dust into the air system, degrading habitability. Belgian notes record intermittent communications, ventilation affected, observation impossible, across multiple blocks, translated excerpts, paraphrase. In fortress design, ventilation and communications are support systems. In this fight, their degradation became combat outcomes. Attempts to retake the roof measured the limits of interior mobility. To mount a counterattack, Belgian squads had to climb shafts or emerge from ground-level exits covered by German fire. Even a delay of 5–10 minutes per movement, multiplied by multiple attempts across the day, accumulated into an hour lost enough for the bridge detachments to strengthen positions and for motorized German relief to arrive. Time is the decisive ammunition in such an operation, Karl-Heinz Seizure observed of Eben-Emael's role within the larger plan. The Blitzkrieg legend, paraphrase. The roof remained in enemy hands. The galleries grew more isolated from the tactical situation outside. Inside, commanders confronted an arithmetic of attrition that did not favor persistence. Magazine stocks remained substantial. However, guns whose cupolas were jammed or whose periscopes were shattered could not fire with effect. The defenders could still bring small arms fire to bear within the fort, and at some embrasures, but the Albert Canal fight had moved beyond small calibers. Without corrected artillery or sustained heavy MG arcs from the fort, Belgian and French formations could not count on the fortress to anchor a coordinated counterstroke along the canal line. A post-action Belgian comment summarized the operational impact. Fort cannot influence bridgeheads. Artillery support uncertain. Enemy reinforcement continuous. Translated excerpt, paraphrase. The word continuous speaks to tempo. Once 2 intact bridges were in German hands, vehicle throughput trucks, guns, fuel rose hour by hour. German decision-making on May 10 reflected economy of force. The assault engineers did not attempt to clear the labyrinth. They avoided casualties in galleries and left the heavy work to incoming ground units. By evening, relief elements had established control around the fortress perimeter, further isolating the garrison. Where cupolas remained potentially serviceable, additional charges were placed to ensure inoperability. Where observation posts might be repaired, periscope heads were re-attacked. We aimed to keep the eyes closed, not to chase men underground. Assault leader Rudolf Witzig summarized in post-action notes, paraphrase. The metric remained binary. Could any major weapon observe and fire on the bridges? By nightfall, the answer was still no. Through the night of May 10-11, Belgian officers assessed options under conditions of disrupted ventilation and rising fatigue. Medical capacity, finite, in any fort, began to bind. Water and power were not catastrophically damaged, but were uneven across blocks, causing additional frictions. Communications to higher headquarters were sporadic. Importantly, the exterior situation had shifted decisively. German forces were now across the canal in strength, and artillery could be brought to bear if required. The calculus changed from hold for relief to preserve the garrison. On the morning of May, 1 times vary by source, negotiations began, and the garrison capitulated. The interval between rooftop neutralization, within 30-60 minutes on May 10, and surrender, May 11, thus stretched to less than 24 hours, a figure that captures how quickly a fortress designed for prolonged resistance became untenable once its decisive organs were disabled. Quantitatively, the defender's predicament can be framed as a mismatch of cycles. Interior movement and repair in galleries took place in units of minutes per task, contingent on safe passage and coordination. German denial actions charges on periscopes, hatches, and turret rings required seconds to emplace and produced persistent effects. Meanwhile, the operational clock outside advanced in hours. Each hour that bridges remained intact added dozens to hundreds of vehicles to the east bank, compounding the garrison's isolation. The fort became a liability by tying troops underground while the battle moved past it, Frieser argued, paraphrase. Belgian files, reticent in tone, still mark the same conclusion. With observation lost and approaches occupied, continued resistance could not alter the canal outcome. Translated essence. This sequence also illuminated design assumptions. Eben-Emael embodied 1,930 seconds fortress thinking, thick concrete, overlapping fields, and armored cupolas dominating predictable avenues. The German method inverted those assumptions with vertical approach. Cupola metallurgy, adequate against splinters and low-angle hits, proved vulnerable to hollow charges correctly seated at weak points. Traverse limits, immaterial against frontal assaults, became disqualifying against attackers on the roof. The decisive element was the combination of air insertion and charge geometry, Witzig later reflected, paraphrase. Where the design assumed recovery time between blows, the attackers imposed parallel strikes that denied recovery altogether. By surrender, the numbers told a consistent story. a garrison exceeding 1,000 men, immobilized by perhaps 80 assault engineers on the first morning, 9 gliders, yielding the operational effect of 2 to 3 intact bridges, less than a day from the first shaped charge to capitulation. Those metrics do not glorify the attackers. They quantify how specific innovations, glider delivery, shaped charges, disciplined packet tactics, converted fixed defenses into sunk costs at the decisive hour. The fort's fall did not win the campaign, but it removed a bottleneck that could have cost days. Eben-Emael's defeat was not a collapse of morale but of function. A fair paraphrase of both German and Belgian records would read. That distinction matters analytically. The garrison fought within its constraints. The constraints were engineered against. Once the exterior fight moved on, capitulation became a rational decision inside. Once observation and key cupolas were blinded, Eben-Emael's interior mass could not be converted into exterior effect. Isolation compounded hourly, as intact bridges elevated German throughput, making capitulation within a day an operational certainty rather than a morale failure. May 1940, Fort Eben-Emael charge geometry versus turret metallurgy. The decisive variable on the roof was not explosive weight per se, but how explosive energy was shaped and applied to armored and reinforced targets. German assault engineers carried purpose-built hollow charges whose geometry concentrated the detonation into a narrow, high-velocity jet. Against cupola steel and mounting rings, this produced penetration or catastrophic spalling with a fraction of the mass that a blast charge would require. In the opening hour at Eben-Emael, this physics translated into a work rate measured in minutes per target. Place, seat, fire, assess, and if needed, follow with a larger plate charge or a flamethrower burst to prevent repair. Belgian turrets and observation posts, designed to shrug off low-angle shell fragments and small arms fire, were not optimized for such axial, point contact effects from above. Metallurgy defined the defensive baseline. The fort's armored elements, cupolas, periscope heads, and ring structures were manufactured from high-grade steel and anchored into reinforced concrete. Exact thicknesses vary in surviving documentation, uncertain. Reported ranges of several centimeters for steel, decimeters for reinforced concrete, but the design assumed predominantly horizontal threat vectors. Traverse gear, periscope clusters, and ventilation heads protruded where designers accepted limited vulnerability to aerial fragments, not to directly seated charges. Protection was calculated for indirect artillery, not for a charge placed by hand on the roof. Assault leader Rudolf Witzig later reflected in post-action notes, paraphrase, "The glider insertion made that hand placement possible within seconds of landing." The hollow charge, Hohlladung, exploited the Monroe effect. A conical or hemispherical cavity lined with metal focuses detonation energy into a jet capable of perforating steel far thicker than the charge's diameter. In practice, the penetration mechanism depends on standoff distance, liner material, and seating. The engineer's checklists therefore emphasized contact quality and angle. A misseated charge wasted explosive. A properly seated one could shatter a periscope cluster or bind a turret race with one detonation. Where a first strike created cracks or deformation, a follow-on plate charge heavier, designed to break concrete rather than penetrate steel, could then immobilize the mount. It was enough to blind and jam, Witzig summarized paraphrase, matching the tactical requirement. Not spectacular destruction, but function denial by minute X. Quantitatively, this approach inverted typical siege arithmetic. Rather than bring tons of shells over hours, fewer than 100 sappers carried perhaps tens of kilograms of specialized charges, uncertain. Individual charges often cited in the 3-12 kilograms class, and achieved an effect normally associated with far larger bombardments. The effect-to-mass ratio was enormous. Two metrics capture the productivity: the reported neutralization of principal roof weapons within to 30-60 minutes, and the ratio of attackers to decisive targets, roughly 1 glider packet per objective. Each successful placement removed a node from the fort's fire control network. The loss of even one major observation post degraded ranging. 2 or 3 silenced cupolas collapsed, overlapping arcs that had been carefully surveyed across the canal. Belgian material performance was not deficient by the standards for which it was designed. Cupola steel resisted splintering and small caliber hits. Concrete covers absorbed blast from near misses. But the problem set had changed. Flamethrower bursts, while not structurally destructive at scale, created thermal shock and forced closures that enabled charge placement. A Belgian garrison note captured the cumulative result. Explosions on massive, observation destroyed, traverse blocked in sectors, translated excerpt, paraphrase. Against a conventional artillery preparation, crews could button up and endure. Against roof teams that attacked specific apertures in sequence, endure, translated into progressive blindness. The engineering contest extended to repairability. Interior crews attempted to clear debris from periscope wells and free jammed traverse mechanisms. Here the gallery architecture worked against speed. Moving tools and men through corridors and upshafts added minutes to every task. Meanwhile, exterior packets could re-attack within seconds. Parallel, repeated strikes prevented recovery. Historian Karl-Heinz Frieser argued, framing Eben-Emael as an instance where the attacker controlled the maintenance cycle as well as the damage cycle. The Blitzkrieg legend, paraphrase. In other words, the Germans did not just break things. They set the tempo at which the defenders could try and fail to fix them. Several design judgments illustrate the narrow margins involved. A periscope head offers a small target, yet its destruction removes ranging for an entire sector. A turret ring is rugged. Jamming it for even a few degrees of traverse can eliminate an interlocking field of fire that protects a bridge. In each case, the material succeeded as a component, but failed as a system once precision denial accumulated. Fortresses are systems neutralize the indispensable organs, and mass becomes inert. Frieser observed, paraphrase. The Eben-Emael outcome vindicated that systems view, charge geometry applied at critical points, converted robust metallurgy into isolated weight. The lesson did not imply that all forts would fall to small teams. Weather, approach warning, and roof access conditions could have altered the calculus. Historiography. Accounts differ on the extent to which surprise was decisive versus the charges themselves. Still, the measured outputs at Eben-Emael 9 gliders to 75-85 sappers, key weapons neutralized within to 30-60 minutes show that, given access and time on target, shaped charges can outperform conventional blast techniques by orders of magnitude per kilogram. That performance, multiplied by synchronized bridge seizures, produced the operational effect German planners needed: intact spans and a preserved timetable to the Meuse. Belgian records, conservative in tone, do not contest the root mechanism. They describe the presence of enemy on the massif, the destruction of observation, and the disabling of cupolas, translated excerpts, paraphrase. Each line is a materials verdict. Geometry and placement overcame thickness and traverse. In that technical sense, the fall of Eben-Emael belongs as much to the laboratory as to the battlefield. By applying hollow charge physics to the fort's least defended axis, small teams translated precise joules into systemic paralysis, proof that, at Eben-Emael, charge geometry, not explosive mass, dictated outcomes against otherwise sound metallurgy. Le 10 mai 1940, Liège Sector vertical, envelopment vers, fixed gun, traverse limit. The decisive asymmetry at Eben-Emael was geometric. The fort's cupolas and casemates were engineered to dominate predictable horizontal avenues of approach canal, roads, and fields through traverse arcs surveyed years before 1940. Elevation and traverse tolerances reflected that assumption. By contrast, Sturmabteilung Koch approached on an axis the fort did not meaningfully contest, straight down onto the roof. 9 DFS 230 gliders, plus or minus by source, carrying roughly 75-85 sappers, converted the roof from an observation platform into an access point. Once there, the defenders' chief strengths armor, concrete overlapping arcs, were converted into liabilities by their own mechanical limits. Cupolas could traverse, but they could not elevate to engage men working within meters of their crowns, and casemates by definition could not fire upward at all. Vertical insertion also altered the detection problem. With engines cut, the glider's acoustic signature fell drastically. Landing rolls measured in tens of meters allowed touchdown within weapon length of objectives. Uncertain. Exact roll distances vary by surface and load. By the time interior crews recognized a rooftop incursion, the first shaped charges were already being seated. The time delta is the crucial metric. It takes seconds to seat a properly prepared hollow charge, but minutes to organize and move a countersquad through galleries and up a stair or elevator shaft. Landing on the massif was the only method that made the fort's weapons irrelevant at the outset. Assault leader Rudolf Witzig later wrote in post-action notes, paraphrase. In practical terms, elevation limits that were inconsequential against artillery shells became absolute against a sapper kneeling on armor plate. Traverse constraints scaled the problem further. Even if a cupola could depress marginally to fire at a roofline, its traverse rate and firing aperture made continuous engagement of fast-moving rooftop targets improbable. Periscopes gave awareness, not aim. And once periscope heads were shattered by the first detonation, the remaining traverse capability lost meaning. Belgian interior notes captured the sequence with understatement. Observation destroyed, traverse blocked in sectors, fire without correction ineffective, translated excerpt, paraphrase, without observation. Traverse is motion, without purpose, a measurable degradation from surveyed arcs to blind rotation. The bridge fight amplified these geometry effects. At Vroenhoven and Veldwezelt, 2 to 3 critical spans seized intact. The absence of fortress-directed, observed fire changed the calculus in meters and minutes. With intact bridges, German troops maintained column density and crossing rates that a destroyed span would have reduced by orders of magnitude. The upstream cause of that throughput was geometric denial at the fort. Vertical approach to the roof removed the one capability that threatened the bridges at range. Tempo came from eliminating bottlenecks, not from mythical velocity. Historian Karl Heinz Frieser argued, using Eben-Emael to illustrate how a single geometric mismatch could unlock an axis of advance. The Blitzkrieg legend, paraphrase. Quantitatively, the mismatch can be expressed as a ratio of clocks and angles. The attacker's critical tasks land, move 20-50 meters to an objective, uncertain, approximate rooftop distances, place a charge, fire fit inside a 1-3-minute microcycle. The defender's critical tasks, detect, communicate, move a squad hundreds of meters internally, ascend fit inside a 5-15-minute microcycle, longer if smoke or damage forced rerouting. Against that disparity, the mechanical facts of cupola elevation, uncertain, degrees of upward travel by model, and casemate orientation imposed hard ceilings. Our armament is designed for the plane of fire. The enemy fought from the plane of the roof. A Belgian post. Action comment essentially conceded. Translated paraphrase. In systems terms, the attacker operated inside the defender's decision and movement cycles. Vertical envelopment also neutralized traditional counter-preparation. A fort optimized for horizontal threats would ideally receive artillery support to blanket the attacker's assembly areas, yet the gliders bypassed assembly altogether by arriving as discrete packets directly on the objective. Even if supporting Belgian batteries had perfect timing, indirect fire onto the fort's own roof was a politically and practically unlikely remedy, and, without observation, impossible to adjust precisely. Thus, the fort's own geometry and place to protect the bridges ruled out heavy friendly fires that might have dislodged the rooftop teams. The fortress became self-shielded terrain for the attacker, paradoxically protected by the very arcs meant to defend it. Seizure observed. Paraphrase. The lesson was not that cupolas were obsolete, but that their integration needed a vertical counter-capability, close, in roof defense, rapid, response stairwells, or roof-mounted light weapons with depression divided by elevation envelopes tailored for near-surface engagements. Historiography. Some interwar designers proposed limited roof defenses. Implementation varied widely and was often sacrificed to cost. Eben-Emael's designers had provisioned thick armor and robust traverse gear, excellent against indirect fire and low-angle assault, but had not optimized for a glider-delivered sapper within arm's reach. In material terms, this appears as a mismatch between designed angles and encountered angles. In operational terms, it appears as minutes saved for the attacker and lost for the defender. Importantly, vertical envelopment was a multiplier rather than a standalone doctrine. Its effect depended on synchronized ground operations at the bridges and rapid relief. The numbers remain the most honest summary: 9 gliders to 85 sappers, key roof weapons neutralized into 30-60 minutes, 2 to 3 bridges held, a garrison of 1,000 plus, unable to project decisive fire during the critical window. Witzig's post-action paraphrase, identify and strike the indispensable organs, and a Belgian line. Observation impossible, communication intermittent, are two sides of the same geometric fact. Once the fight moved onto the roof, traverse limits that were prudent in design became disqualifying in combat. By attacking along a vertical axis, the fort's weapons could not meaningfully engage. The glider teams compressed action into minutes, while cupola elevation divided by traverse limits stretched Belgian response into tens of minutes, an angular mismatch that cascaded into bridge throughput and Meuse front tempo. May 10-12, 1940, Maastricht, Liège Axis Bridge, capture vehicle throughput operational tempo. The operational value of Eben-Emael's neutralization appeared not on the fort's roof but on the roads that fed the Meuse. With Vroenhoven and Veldwezelt held on May 10, intact spans replaced what would otherwise have been 24-48 hours of bridging work under fire. For 6. Army, driving west under General Walter von Reichenau, that substitution expressed itself in vehicles per hour and tons per day rather than in headlines. The canal to Meuse distance in this sector was short, measured in single-digit kilometers, uncertain, to 3-8 kilometers depending on route, but the clock advantage was large because a stationary column loses tempo exponentially as rear echelons stack up. 2 to 3 functioning bridges kept march tables plausible and prevented a rolling traffic jam from collapsing the day's plan. Even conservative throughput arithmetic makes the relationship visible. If a single undamaged road bridge can safely pass roughly 10, 12, 15 vehicles per 10-minute cycle under traffic control, illustrative, uncertain, that equates to 60-90 vehicles per hour. 2 bridges in parallel Vroenhoven and Veldwezelt double the lane count and have average wait times. Across a 10-hour daylight window, the cumulative effect is hundreds of additional vehicles, guns, signal trucks, fuel carriers, west of the Albert Canal by nightfall. What the literature calls blitz is often the removal of a single bottleneck, Karl-Heinz Frieser argued, using the Albert Canal as a case study in throughput physics, the Blitzkrieg legend paraphrase. In short, neutralize the fort's eyes for 30-60 minutes, keep 2 spans intact for a day, and the Meuse crossings the following day become a scheduling problem, not a bridging problem. The German staff measured progress in march tables and tonnage receipts. Units scheduled to arrive at line of departure points along the Meuse on May 11-12 did so without the slippage that a destroyed span would have imposed. Bridging under fire is not merely slow, it is sequential. Engineers must clear demolitions, emplace pontoons, and then meter the first crossings, all while under observation. By contrast, an intact span runs from minute 1. A Belgian post-action note, stark in its implications, recorded, "Bridge charges partly removed. Enemy holding with machine guns. Artillery support uncertain." Translated excerpt, paraphrase. The word uncertain captured the condition created at Eben-Emael. Without observation, Belgian guns could not range the bridges reliably, and the German crossing plan ran on schedule. One way to see the tempo gain is to track heavy weapons. A 105 mm battery requires prime movers, ammunition trucks, and a minimum road interval to avoid bunching. If the first batteries clear the canal on May 10 instead of May 11, they can register on Meuse approach targets by the morning of May 11, not the evening. That difference moves fire support forward by one tactical cycle. Fuel matters similarly. A typical early war truck carried on the order of 1-3 tons, uncertain model, dependent. Each additional 100 trucks over intact spans adds hundreds of tons of fuel and supplies to the West Bank during day 1, a compounding reserve that keeps the lead elements from pausing before the Meuse. Tempo is simply uninterrupted logistics, Frieser wrote, dismissing mystique, paraphrase. The human factor tracked the same curve. Column commanders report differently when their trucks move on time. Orderly crossings sustain morale and discipline. Delays induce improvisation at the company level that can fracture march integrity. The captured bridges stabilized behavior upstream. A captured Belgian remark from the sector sums the operational linkage, even while lamenting the local outcome. Bridgehead stabilized because fort observation was lost. Enemy reinforcement continuous, translated excerpt, paraphrase. Continuous is a logistical adverb. Critically, the tempo gain at the Albert Canal translated into choice space at the Meuse. Reaching the river's east bank with columns intact on May 11 allowed 6. Army to distribute pressure, scout for best crossing sites, and force or feint without waiting on engineers to catch up. That flexibility exerted pressure on Belgian and French timelines. If defenders require the night of May 10-11 to align reserves and prepare demolitions, but find German units already probing on the morning of the 11th, their own decision cycles compress. Minutes saved at the canal became hours taken at the river. At Eben-Emael, tactical innovation bought operational time. Assault leader Rudolf Witzig noted in a post-action paraphrase, framing the glider attack as a temporal exchange, shaped charges for hours. The numbers established earlier remain the skeleton key: 9 gliders to 70, 585 sappers, principal weapons neutralized into 30-60 minutes, 2 to 3 bridges held, a garrison of 1,000 plus, rendered functionally unable to interdict the canal crossings. From those inputs came outputs that staff officers could plot. Scheduled arrival times honored, fuel stocks maintained, artillery brought up without detour. The short geographic span between the Albert Canal and the Meuse magnified the effect, because every hour preserved at the canal appeared at the Meuse almost undiluted. Had either Vroenhoven or Veldwezelt fallen into the river, even temporarily, the march table would have slipped by half days, and the correlation of forces at the Meuse on May 11 would have looked different: more defenders in place, more time for demolition and artillery sighting. This is not to say the canal victory decided the campaign. It did not. But as an engineering problem solved on the morning of May 10, it removed a choke point that would have forced a different operational cadence. The fort's fall and the bridge's capture combined to maintain momentum at precisely the moment when Allied command still hoped to throw a line across the river. In that sense, Eben-Emael's rapid neutralization and the intact spans did not create speed. They prevented slowness. Road throughput, not fort size, decided tempo. As the section closure logic has stressed from the start, analytical restatement. By preserving two parallel crossings and silencing the fort's observation during the opening hour, German forces converted a potential 48-hour engineering pause into uninterrupted movement, an arithmetic of vehicles and hours that opened choices at the Meuse on May 11-12. Mai 11-12, 1940, Liège Sector aftermath, historiography, and design lessons. By the evening of May 11, the tactical picture set by the morning's rooftop action had hardened into an operational fact. 2 to 3 critical Albert Canal bridges were in German hands. 6, Army's march tables held, and Fort Eben-Emael's garrison, over 1,000 strong, had capitulated. The sequence invites analysis beyond narrative. How did fewer than 100 assault engineers, delivered by 9 DFS 230 gliders, plus or minus by source, generate effects normally associated with days of artillery preparation? And what does that answer say about interwar fortification design that emphasized armor thickness, traverse robustness, and magazine depth over vertical countermeasures and recovery tempo? The first axis is method. The German plan decomposed the fortress into indispensable organs observation posts, cupolas with surveyed arcs, and communications nodes, and assigned a packet per organ. The metrics were binary and time-bounded, silent or not by minute 30-60. That framing explains why success did not require clearing galleries or killing large numbers of defenders. We aimed only to blind and paralyze. Assault leader Rudolf Witzig recorded in post-action notes, paraphrase. The shaped charge toolkit converted kilograms of explosive into decisive outcomes at periscope heads, turret rings, and ventilators. Where the first charge deformed rather than destroyed, a second charge or a flamethrower burst prevented repair within the window that mattered for the bridges. The second axis is geometry. Eben-Emael's designers correctly anticipated low-angle threats and built to resist them. They misscoped the high-angle, near-surface threat from small teams, arriving soundlessly onto the roof. Cupola elevation limits and casemate orientations that were irrelevant against artillery became absolute against a kneeling sapper. Belgian post-action notes admitted as much in substance. Observation destroyed, traverse blocked in sectors, communications intermittent, translated excerpts, paraphrase. In system terms, these are not morale statements. They are function statements. The defenders remained numerous and supplied, yet key subsystems, eyes, coordination, stabilized arcs were offline at the exact hour when downstream bridges required protection. A third axis concerns recovery cycles. Fortress doctrine assumed that, after a blow, crews could move tools through galleries, clear damage, and restore partial function. The rooftop packets denied that rhythm by reattacking in parallel. Each reattack took seconds to prepare. Each repair effort took minutes to organize and move. Parallel strikes denied recovery. Karl-Heinz Frieser wrote, arguing that tempo at Eben-Emael derived from control of the maintenance cycle as much as from initial surprise, the Blitzkrieg legend. Paraphrase. The measured outcome principle roof weapons neutralized within to 30-60 minutes reflects the asymmetry of those cycles. Quantitatively, the downstream effect is easiest to see as a schedule kept rather than a feat performed. 2 to 3 intact spans at Vroenhoven and Veldwezelt sustained vehicle flows measured in scores per hour. Across a 10-12-hour window on May 10, that meant hundreds of additional vehicles, guns, fuel trucks, command assets west of the Albert Canal before midnight. Illustrative. Exact counts vary. By first light on May 11, probing elements stood on the Meuse. The defenders' calendar contracted by roughly a day. At Eben-Emael and the Albert Canal, tactical invention purchased time hours at first. Then a day, Frieser concluded, paraphrase. That exchange of shaped charges for time, glider landings for intact spans, is the campaign-relevant ledger entry. Historiography reflects broad agreement on mechanism with debate at the margins. One view emphasizes surprise and Belgian command friction. Another weights the material breakthrough of hollow charges and the geometric mismatch. Historiography. Both threads appear. Balance varies by author. The sources agree on the non-negotiables. 9 gliders plus or minus, to 70, 5, 80, 5 sappers, key weapons neutralized into 30-60 minutes, bridges at Vroenhoven and Veldwezelt seized and held, garrison capitulation on May 11. These are not rhetorical figures. They are the bones of the event from which any interpretation must be built. The design lesson is not that forts are obsolete. It is that fixed defenses must be integrated with vertical counters, roof surveillance and warning, ready roof teams, close-in weapons with elevation divided by depression envelopes tailored for near-surface fights, and redundant observation paths hardened against point-contact demolition. Eben-Emael's armored mass and traverse gear excelled at the problem it was built to solve. It failed against the problem that arrived. A fortress is a system. Remove observation and coordinated fire, and you have weight without effect. Witzig's paraphrased line and Belgian records together imply. In procurement terms, that is a resource allocation warning. Thickness without recovery and vertical coverage is an incomplete investment. Finally, the episode reframes blitzkrieg as logistics protected by engineering. The neutral tone of staff tables, vehicles per hour, arrival times, fuel tonnage, tells the real story more cleanly than any rhetoric. On May 10-11-1940, a small airborne force, by attacking along an unguarded axis and applying modern explosives precisely, created a time window that 6th Army exploited to reach the Meuse on schedule. The fort fell, the bridges stood, the road filled. That chain bridge capture vehicle throughput operational tempo remains the analytic takeaway. Eben-Emael demonstrates that a fortress can be defeated as a system by denying observation and traverse along a vertical axis faster than it can recover. The preserved bridges turned those minutes into a day's advantage at the Meuse, where schedule, not spectacle, decided tempo.